Hey, Math One, this is Miss Robert Shasta High School, and it's time to start our homework. We're beginning at question 86 tonight. This first question says, human resource manager recorded the experience and hourly wage for a sample of 10 technology workers. Okay, looks like a very small data set. I don't know what I can decide from that, but we're just practicing setting up some stuff here. So it says, sketch a scatter plot showing the association between wage and years of experience and describe the association. So, okay, we'll start with the scatter plot. Let's do that. I'm going to, without clicking on anything in the ebook, I'm just going to jump to Desmos. Oh, please. Oh, there it is. And inside of Desmos, we'll just start by, whoa, get back up here. We're just going to start by entering our table. So remember, to enter some data, we just go ahead and hit plus. I'm going to hit a table, and my table has some X's. The X's are years of experience. I'm just going to type 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Really? Oh, no, don't put 11. 8, 9, 10. No one had the same number of years of experience? Okay. So I got 1 through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. And then their hourly wages are 12, 13.25, 14, 16, 17, 18, 19, 50, 21, 22, and 23.5. Probably these should, oh no, 23.25. Probably these numbers should be adjusted for inflation, but they're not. Okay, so as I'm looking at this, I can't see the scatter plot at all, right? I'm looking like, where's the scatter plot? Now, I'm happy with the 1 through 10 for X. I'm going to stretch X over, so it's pretty much 0 through 10 there. But I need to bring this down because my smallest value is 12 and the biggest is 23. So when I bring these down, this is the data I'm looking at. And there is my scatter plot. And it says, okay, so if I was to go Control Shift S, I can grab this thing, copy this thing, and I could paste this thing, right? So it does say, so it says describe it, and then it says describe the association. No, it says sketch it and then describe the association. So, a quick sketch of this is adequate. You don't have to go crazy about it, but you can see what's going on there. And it says, I would say that clearly there is an association. The more years experience that you have, right, the greater your salary. And I can see that, right? It's got a positive slope. It's increasing. Next, it says, sketch the residual plot. Is a linear model appropriate? So the idea we keep coming back to is if we see some kind of a pattern in our residual plot, we say, we don't know that a linear model is appropriate, right? But let's go ahead and sketch this. And to sketch the residual plot in Desmos, the best thing to do is to go ahead and figure out the LSRL. So I'm going to do that, and I'll remind you how I do that. My data was set up so that my Y's are in list 1 and my X's are in list 1. So I typed the following. I'm going to say Y1, and all I did was I just typed Y and the number 1, and it made it a subscript. Y1 and then tilde, that's up by the escape key, shift, and apostrophe, I think. Yeah, tilde. And then I'll just type MX1 and then plus B. Boop. There we go. Hey, just like that, I know the equation of my least square regression line. The equation is y equals about 1.3, if I was rounding to the nearest tenth, 1.3x plus 10.6, right? Next, I'm going to, it said make a residual plot, so I'm going to hit this button and boom, there they are. They're down here along the x-axis. These are the residuals. And if I want to make this look like a proper residual plot, 0 should always be in the middle of a residual plot. I'm going to turn off the scatter plot. I'll turn off that. And I'm also going to turn off my line of best fit. And the other thing I might do is stretch this out so that 1, right? So when you look at this and you read across, you say, oh, look, take a look at this. All of my residuals, right, are within 1, right? The biggest residual I have is right here. This one was when X was 3. This was negative 433. which is interesting. If I went back and I looked at data set 3, this person right here that was getting $14 an hour, that was actually below what the model predicted, right? So in fact, if I think about that, if I'm thinking about, my salary, especially if I'm comparing with a large database, if my salary is like below the LSRL, I'm like, you know what? I'm doing something wrong. And I mean I'm always doing something wrong, but maybe I can get more money. Maybe I can increase my skills somehow and do more. I don't know. Okay, so next it says sketch the residual plot. Is a linear model appropriate? I would say absolutely. So one of the things that would make me reject a linear model is if I saw, positive residuals becoming negative, becoming positive, right? Anything that kind of suggests a curve, and it could be also negative to negative, but I don't really see anything like that. It's just like above, below, on it, above, below, right? So it's just like kind of they're just scattered out randomly. So I would say I'm happy with the linear model. I would leave the linear model. And then the last thing it says, what is the correlation coefficient? What does it tell you? So let's go back to where we're looking at the actual. I'm going to turn off the residual plot. Can I do that? Yeah. I just turn off those. Huh. Can I get in here? How am I going to do this? Oh, there. Turn those off. Bringing this back over here. So there it is, and I'll turn back on the line. So the correlation coefficient is positive. You can see it, the numbers right here. Right, the number is positive 0.9985. Okay, first of all, the fact that it's positive tells me that this is an increasing association. As hours of experience get better, right, or the years of experience increases, my hourly salary or hourly wage goes up. So it's positive. And the fact that it's so close to plus one, right, it's very close to positive one. This is a very, very strong association. There's a strong association between these two variables in this particular data set. All right, let's move on to question number 87. Here you are, 87. It says, Marissa went with her friends to an amusement park on a beautiful spring day. The park was crowded. Marissa wondered, oh, Marissa, just enjoy your time at the park, right? Don't. Okay, she's doing it. Marissa wondered if there was an association between the weather and attendance. From data, what did she do? She's like, forget it, I'm not getting a line to go on a ride. I want to go to the office and talk to management. So from data she received at the theme park office, Marissa randomly picked 10 Saturdays and analyzed the data. Okay. Marissa calculated the least square regression line. Oh, okay, so that's cool. So we know what the line of best fit is, right? We don't have to wonder. This is the least square regression line. Thank you. Where A is the attendance and thousands of people. So if I put a number in there and I get 2, that doesn't mean 2 people showed up. It was 2,000, right? So whatever this says, there are thousands. And T is the high temperature measured in degrees Fahrenheit that day. Interpret the slope in this context. Okay. So for this model, what it looks like is that as the temperature increases, more people come to the park. In fact, this is the slope, right? So the slope in this context is 0.41. So that's every time the temperature increased by a degree, 0.41 thousand, or about 410 people more would come to the park, right? So it says focus, Robert. It says, and T is, okay, it says, interpret the slope in this context. I would say that the slope is, well, it's 0.41, and it's thousands of people per degree Fahrenheit. So as the temperature increases by 1 degree Fahrenheit, right? That's the run. The people in the park is going to increase by 410. And I know it says 0.41, but remember these are thousands of people. So 0.41 of 1,000 is 410 people. All right, so it's positive. The warmer it is, the more people show up. The residual plot Marissa created is showing it right. Oh, on days when the temperatures were in the 80s, would you expect the predictions made by Marissa models to be too high or too low? Oh, okay, so these are the residuals. And by the way, I see a pattern, right? It seems like the population, the people in the park is increasing, but as soon as it gets too hot, right? As soon as it gets too hot, it's just like, you know what? 90s, hundreds, we're not coming. It's too hot to be there. So what we're seeing here is that okay, let's see if we can interpret this. So I know that it had a y-intercept that was negative, and it's an increasing line. So if I was trying to sketch roughly what the line looked like, look at this. So what we're saying here is, as long as we're like less than 80 degrees, we had some negative residuals and some positive ones. From 80 to 90-ish, from 80 degrees to 90 degrees, all the residuals were positive, right? But as soon as we hit the 90s, right, then we start to get residuals that are negative. So what is this telling me? Remember what these data points are. These are people. Well, no, these are supposed to be people in the park. So let me read the question again. I've just confused myself. It says, on days when the temperatures were in the 80s, okay, would you expect predictions made by Marissa's model to be too high or too low? Oh, they would be too low. The model would be predicting too low. Because you can see, like, the model is here, right? The model's predicting this, but the actual value is high, right? That's one of the things we know. Like, oh, hello, where'd you all go? If we have positive residuals, right, what that means is that a positive residual indicates that the model is predicting too low, right? Because what's actually happening, this is what actually happening, is above the model. So I would say that it would be too low if it's in the 80s, right? I could see this in 80s, all in the 80s, right? Her model was always off. She was predicting positive residual, positive residual, positive residual. So her model is always predicting more people. I mean, her model is predicting less people than were actually there. That's what I'm saying. Next, what is the actual attendance on the day when the temperature was 95 degrees Fahrenheit? Okay, this is going to be tough. 95. Okay. So I'm going to say this data point right here is the 95 degrees. Jeez. And I know that the residual for that day, when it was 95 degrees, the residual I'm going to guess is -7. Okay, bear with me. I know that the residual for that day is -7. Yes, I do. I'm reading it from the residual plot. It's below. And then it says, but okay, so that's the residual. So I remember this relationship, right? The residual is the difference between the actual y value and the predicted y value. Well, what's strange about this question is I know what the residual is, right? The residual I can read from the table, and it's -7. And the question's asking me what's the actual y value, right? And I got one more trick up my sleeve. This is a trick. I know I can figure out what the predicted y is. And I know you're like, how can I figure out that? Right here. This will allow me to figure out my predicted y value. How am I going to do that? Oh, it's easy. But I need a calculator first. I was going to say I need to take a nap, but no. I need a calculator. Turn on the calculator. Where's the calculator? Oh, come on. With calculator? Go. There it is. So let me clear that thing. So what I'm going to do is I'm going to feed 95 degrees in. That's the temperature. And it's going to give me my predicted y. So it's just going to be -14 gotcha, plus 0.41 times 95 degrees. Boom. Okay. So my predicted y is 24.95. And remember, that's in thousands. So it would be 24,950 people, right? 24.95. Now, let's come back over here. We know the residual was -7. We know now the predicted y was 24.95. And the question is, what's the actual attendance? Oh, that's not, I can do this, right? All I have to do to solve for the actual attendance, right, the actual y value, is just take this -7 and I'm going to add 24.95, right? So I'm just going to say 24.95 plus the -7, and I get 17. I get the actual was 17,000. 17,950 people, right? And I wrote it in the thousands, right? So the number, my goodness, the number would be 17.95. You can see on my calculator screen, but the actual attendance that day was 17,950. And then finally, would you rely on this model to make predictions? Why or why not? I would not. Would not. By the way, this answer is right here, right? 17,000. I would not, and the reason why I would not is because of the fact that I clearly see there's this negative residuals, positive residuals, right? And then negative residuals. When I see a pattern like that in a residual plot, it's telling me that there could be a better nonlinear model, right? It seems like, yeah, if it's too cold or if it's too hot, it changes things. So I would say not. I would say I would probably want a non-linear model. And I don't know if that would be like quadratic or exponential or what, but something else, because I can see that it's not so accurate. Actually, it's always kind of a mess. Like it's I don't know. It's never really close. The data points are either under or above. Let's go to the next question. Woo! Next question. That's great. Simplify each expression. Oh, I love this. So this first one is it's 2 to the third, and I'm going to make this over 5 squared. Oh yeah, 2 to the third. That would be the number 8, and 5 squared is 25. It's 8/25. You know, I'm wondering if this calculator will display that as a 2 to the no, not fraction. A 2 to the third. And then I'm going to say time. No, not there. I'm going to leave that and go times. And I'm going to go 5 to the -2nd. What's it say? Oh, yeah, 8/25. That's beautiful. B. Okay. So I have to cube this. That means I need 3 of those. So if I cube it, it's going to be an xy squared, xy squared, xy squared. There are 3 factors of x there. So it's going to be x cubed and then y to the 6th. That's what that first part is, times x to the -2nd. And I was getting all ready to multiply by x squared over x squared, except I realized, like, wait a minute, if I combine those, x to the -3rd times x to the x to the 3rd times x to the -2nd is just going to give me x. So this is xy squared done. These next two are in scientific notation. Oh, and it says for part C and D, write your answer using scientific notation. All right, so 3 times 4 is 12. Gotcha. Times, and then I go 10 to the 3rd times 10 to the 5th is times 10 to the 8th. Now, that's the value, right? But that's not in scientific notation. So what I have to do is I have to make it look like 1.2. And if I multiply 1.2 times the value of 10, right, what I have now is exactly the number 12. But I had this other times 10 to the 8th power that was already up here before, so I have to bring that down. So if I look at this now, it's 1.2 times 10 to the 1st, if you will, times 10 to the 8th, it looks like we're going to get, this is going to be 1.2 times 10 to the 9th power. 1.2 10 to the 9th. And the last one in this group is, let's see, 4 divided by 5. That's the same as 8 divided by, I think this is 0.8. So I got 0.8, right? That's when I do the 4 divided by 5, I get 0.8. And then 10 squared divided by 10 to the negative second. Oh, I got a trick for that. I'm going to multiply by 10 squared over 10 squared, right? So in the denominator, 10 to the negative second times 10 to the second is 10 to the 0, which is equal to the number 1. And in the numerator, I have times 10 to the 4th power. Now we got a problem, right? That's not in scientific notation. So I need it to be 8.0. But in order to make 8.0 look like 0.8, I have to divide that by 10. So I'm gonna multiply it by 10 to the negative first, right? And you can verify on your calculator if you don't believe me. I know you're sitting there like, Roberts, that's not right. If I take 8 and I multiply it by 10 to the negative first, 8 times 10 to the negative first is going to give me 0.8. Then I'm just going to go ahead and bring down this other part that I had, right? We had this, this 10 to the 4th. And when I bring that down, now I can combine those and I get 8.0 times 10 to the 3rd power. There we go, 10 to the 3rd. Nice. For each graph below, what is the domain and what is the range? And then it says, which of any of the graphs represents a function? Okay, so I'll do some notation here. So for this first one, I'll say the domain is going to be the x's from -2 to +2, right? X's are those things that go from -2 to +2. That's the domain. And the range of this function, right? Those are my y values. My ranges are those things from -3, looks like -3, all the way up to +2. So I'd say the range is going from -3, and the range are the y values, up to +2. Domain and range. Oh, the next one. What is the domain of this? The domain is a single number, right? The only value right here, the domain is x is 2. That's it. There's nothing else I can put in that thing. The only value that gets an output is that x is 2. And the range, you can see it, right? The range is, it's got these arrows indicating that it goes on forever. So I'd say it's just all numbers or all real numbers. It's all real numbers. Yeah, it's all of them. No, this is fancy. Okay, so I can see that this thing starts at -2. So I'd say the domain, right? The domain is -2 and everything bigger than -2, right? So the domain is all x's that are greater than or equal to -2. So as long as you're bigger than -2, you're in the domain. Everything less than -2 is not. And then the range, man, these arrows, right? Eventually they're going to hit everything. One of them is going to hit everything to the negatives, and one's going to hit everything to the positives. So I'd just say the range is going to be, again, all real numbers. All reals. And then it says, one of the things, which, if any, of the graphs represents a function? Only one of them, right? Only one. B is not a function because no matter what you give it, x is going to be anything. When you give it x is 2, y could be anything you want. And C is not a function because I can clearly see that there are values of x. Like this value of x right here clearly has 2 different y values, so that's not a function. But A is a function. A is a function because in A, each value in the domain has no more than one value in the range. So it is a function. All right. Woo! This next one scares me. What the heck? So I am given a function f of x. There's the definition of it. And it tells me that this function does the following. It takes 4 as a base and it raises that base to the input, right? So 4 to the 0 and then +1. So for this first one, this is what? It's 4 raised to the 0 power plus 1. Well, 4 to the 0 power is 1. Anything to the 0 power is 1. And then therefore that's 2. So when I give that 0, it gives me 2. This next one, geez, it's a cube root of negative 27. Wow. So what, I guess that's my first question is like, well, what is the cube root, the cube root of negative 27, not 20, 29, 27. Well, I'm going to cheat. I don't know that this calculator does cube roots. Oh yeah, it does. Oh, that's fun. So what I'm going to do is I'm going to enter this. No. So I see what you do. I want a cube root, so I'm going to hit a 3 and then second that. So it made this 3 a little bit smaller. It's a cube root. If I ask what's the cube root of 8, it says 2 because 2 times 2 is 4 times 2 is 8. So it tells me, and that's kind of like, we can think about the square root. So if I say what is, and I could do it here, what is the square root of 9, right? That's all that is. It's going to tell me 3 because 3 times 3 gives me a 9. So when I'm asking for a cube root, I'm asking for 3 factors that such when I multiply them together, and they're all the same factors, 3 factors that I multiply together is going to give me an 8. Well, that's 2. 2 times 2 is 4 times 2 is 8, just like 3 times 3 is 9. So for the cube root of negative 27, let's look at this. So I want the cube root of negative 27. And I know the cube root of 27 is 3. You know what? I think this is a negative number. I think this works. It does. Because negative 3 times negative 3 is positive 9, and positive 9 times another negative 3 is root 27. So that's fun. This is what? It's negative 3 times a negative 3 times a negative 3 is 27. So this cube root of negative 27 is just negative 3. So here's the thing. I'm putting negative 3 into this function. Negative 3 is going in. Negative 3 is going in. Okay, so let's do it now. So that's 4 to the negative 3rd power plus 1, which is what? That's 1 over 4 to the 3rd plus 1. What's that? That's scary. That's what that is. 4 times 4 times 4. 4 times 4 times 4 is 64. So this is 1 over 64 plus, I'll say 64 over 64. I'm just turning that 1 into a 64s. And now I got 1 over 64 plus 64 over 64, which is my best friend today is 65 over 64. So when I plug in the cube root of negative 27 into that function, I get 65 64s. And then it says finally, what is x? Oh my gosh, I can't do this. What is x if f of x is 17? So what they're telling me is, it says figure out what x is if the function, which is what, 4 to the, was it 4 to the x? Yeah, 4 to the x plus 1, if the function equals 17. I can do this because that's 4x is equal to 16. Oh yeah, watch this. I'm going to rewrite this. 16 is 4 to the 2nd power. And over here I got 4 to the x power. Guess what? X is 2. That's very surprising. That's beautiful. That's wonderful. X is 2. So when x equals 2, that function becomes 17. All right, are we done yet? Oh, last question. That's so exciting. It says find the get over. Where'd that go? I'm sorry. I'm back at the beginning of the chapter. Just a minute. I gotta be careful because I don't notice that I have that calculator on the screen, and I think it was covering up that last part there. So I apologize. But I'll just leave this work here for a minute. So yeah, I set 4 to the x plus 1 equal to 17. Then I took away 1 from both sides, and I remembered, oh yeah, 16 is 4 squared. So that's why I was able to get that this is 2. And then you could check it, right? 4 squared is 16 plus 1 is clearly 17. So it works. Last question. It says write the equation line passing through, and then they give me some points. So I remember that I need to know my slope and I need to know my y-intercept. And for slope, I'll do 1 minus 7. You can see I took the y from the first point and subtracted the y from that second one. And in my denominator, I'm going to write negative 3 minus 9. Same pattern. First minus the second is what I did. 1 minus 7 is negative 6. And negative 3 minus negative 9, 9, 10, 11, 12 is negative 12, which is so cool because that's going to make this positive 1/2. So my slope, m equals positive 1/2. And now I need to find my friend the y-intercept, right? So to find the y-intercept, I'll use this point, I'll use the x and the y from this point. What do I know? I know that because y equals mx plus b, that if I'm trying to figure out what b is, I could just take away mx from both sides, right? So y minus mx is going to give me the b that I seek. This is the b that I wish to find. So in this equation, I'm going to put in y as 1, right? I'm going to put in the y that was 1 minus my slope, which is 1/2, times my x, which is negative 3. And that equals b. That's great. 1 minus, let's see, negative 1/2, or 1/2 times negative 3 is going to be negative 3/2. So that looks like 1 plus 3/2. And I can always take the number 1 and make that 2/2. 2/2 plus, not 2/2. 2/2 plus, I had 3/2. And 2/2 plus 3/2 is 5/2. So b is 5/2. So I know now both my slope and my y-intercept. So I can do what? I can say y is equal to 1/2 times x plus 5/2. And pretty confident in that, but I'm going to do a quick check to make sure I'm right. And this time, to do this check, I'm going to tell my calculator to create a table. So I'm going to hit table. Now that I've hit table, it says enter a function. My function is 1/2 times x plus 5/2. And I'm going to make it, it'll start at 0, and I'll have it step by 1, and I'll do auto. Boop, there we go. Okay, so first thing, if I give this negative 3, what's it give me? Well, watch, there's negative 1, negative 2. When I give it negative 3, it gives me back 1. So I can see that, yeah, for this table I entered, negative 3 gives me 1, and then I need to go check 9. If I give this function 9, it gives me 7, right? This is it. 9 gives me 7, negative 3 gives me 1. What more can you want? That's it. That's the equation line. And that is the end of homework for the evening. All right, this is Mr. Roberts. Talk to you later. Thanks for stopping by.